Hello students, welcome once again to our chemistry classes from Spark Academy. Let's today we discuss IP P block elements. So P block elements, it is the vast and easy chapter in second year chemistry. So in that P block elements, so weightage is 8 marks question 1. So how many 8 marks question 1? So 4 marks question I have a chance to, okay, 1 or 2. And what about the 2 marks? 2 plus 2 means if 8 marks is 1, 4 marks is 1, 2 marks is 1. Yes, this is the weightage once again, 8 marks. 4 marks 4 plus 4 and 2 marks 2 plus 2. Yes. Join us for free live classes daily. Download our app Spark Academy. Admissions open 2022-2023. Classroom online coaching. Shorter crash courses, regular courses available. Daily live classes. In session doubt clarifications, free material in our app, tips and tricks and previous year's questions also available. It is our timetable, our live sessions. So every day starts from 11 a.m. to 12 p.m., 5 to 6 p.m. and 6 to 7 p.m. So here use my coupon, yes. ACI 10, it's my coupon. Use this coupon everyone and see the free live classes. So first concept. So what is our concept here? P block elements. So what are P block elements? So we know all periodic table elements. Total 118 elements, they are divided into blocks. S, P, D, F depends on their electronic configuration. So differentiating electron means last electron enters into the P subshell. Such block elements are called P block elements. See, this is the modern periodic table. In modern periodic table, so group number 13, group number 14, 15, 16, 17, 18. So group number 13 to 18 elements called P block elements. In P block elements, the first group is boron family, second is carbon family, third is nitrogen family, fourth is oxygen family, sixth is fluorine family, and seventh one is noble gases, noble elements, 18th group. So these all are P block elements. So what is the general electronic configuration of the P block elements? The general electronic configuration of the P block elements is NS2. So what about general electronic configuration? NS2, NP1 to 6. So NS2, NP1 to 6 is general electronic configuration of the all P block elements. So P block elements in that 13th group enters into what here? NS2. What about NP? 1, 2, 3, 4, 5, 6 by this. Is clear? As link in description, Spark Store. So long term courses, crash courses, mock test. So JEE Mains, NEET, Eamcet, IIT Foundation, available in our Spark Academy. Admissions open, join now. Classroom coaching, offline classes, online classes available. So short term coaching timings, regular coaching timings offline. Crash courses also coming soon. our branches Naranguda and Medipatnam. Now see the live courses NEET 2022, JEE Mains and Eamcet also available. So apply the coupon here. As daily on demand live sessions also available. So the assignments every day, weekend test and total test details you get. Okay, so average time taken here how much? So grade also you will get immediately. Yes. Okay, this all things available in our Spark Academy. Now our methodology. What are our methodologies? Basic concepts. For any subject, basic concepts are very important. So shortcut methods, because we are along with IP we are writing. Okay, we are going to attempt the JEE Mains and entrance test. All model questions, exercise questions, previous year questions, chapter-wise test. So we take the chapter-wise test, weekend test, grand test, test analysis also there. So these are our why Spark Academy, highly experienced faculty, personalized coaching, process-oriented coaching, personal mentoring and doubt clarification. Okay, limited batch size, all are our parameters. So hybrid coaching, as online coaching, no access, these are all our parameters. So join now Telegram link also in that. Okay, Spark Academy, my online, yes, there, and in that all material you will get. As now, okay, in this P block elements, yes, in P block elements, what are the questions? Questions are, we see first as, okay, 8 marks question. Yes, see the 8 marks question. How is ammonia manufactured by Haber's process? Yes, ammonia, okay, it is a nitrogen hydride. So what is ammonia? Ammonia is nitrogen hydride. So what is the formula of the ammonia? NH3. So it is nitrogen is the P block element, it hydride is NH3, ammonia. So ammonia has basic in nature. So how is ammonia manufactured by Haber's process question? So here ammonia manufactured by Haber's process. Haber-Bosch process, just Haber process is basically one of the most efficient and successfully industrial method. So the industrially employed so many methods there. So employed method which one? This Haber's process method. So German chemist Fritz Haber along with his group they did this experiment. So preparation or manufacture of the Haber's process. Yes. Now in yes. So formation of ammonia by Haber's process. In that first step is formation of ammonia. So how ammonia will form? So how many moles of the nitrogen gas is required here? So nitrogen is 1 mole, En2 1 mole. How many moles of the hydrogen gas? 3 moles. So how many moles of the here ammonia gas will form? 2 moles. So this is the number of moles in formation of the ammonia. So the Haber's process combines nitrogen from the air with hydrogen derived mainly from natural gas, okay, into the ammonia. En2 plus 3H2 given, okay, 2NH3. Now question. So this manufacture of ammonia is exothermic or endothermic? It is exothermic or endothermic reaction. So heat of reaction is negative. Yes. So it is exothermic reaction. So energy released. How much energy released here? 92 kilojoules per mole energy is released in this reaction. So what is the flow chart? How we prepared here? See, we prepared nitrogen from air, hydrogen from natural gas. So how much value? 1:3 by value. So what are the favorable conditions required here to prepare the here liquid ammonia? So here 400 to 450 degrees temperature is required. So what about the here this pressure is 200 atmosphere. What about here catalyst also required? What is the name of the catalyst? Iron. Finely divided iron acts as a catalyst in this reaction. So this is the flow chart explaining what are the favorable conditions to form the ammonia. So temperature, pressure, catalyst. Essential manufacture of the ammonia. Now the reaction proceeds in the forward direction with a remarkable decrease value, and thus the reaction is exothermic. In accordance with Le Chatelier's principle, because Le Chatelier explained the process of the ammonia manufacture. So here temperature approximately how much? 700 Kelvin. Yes. So catalyst is iron. So here equilibrium attained, because here rate of the forward reaction, rate of the backward reaction, they are in equilibrium. So it is the preparation of the ammonia. So preparation of the ammonia. So what are the favorable compulsory things? Things are temperature. Yes. So temperature we used here. Temperature, yes, optimum temperature. So next what? Volume, atmosphere. Next iron catalyst. Clear? After, how does ammonia react with zinc sulfate, copper sulfate and silver chloride? Yes. So here ammonia in the form of the ammonium solution. Ammonia in the form of ammonia. Ammonium solution. This ammonium solution reacting with zinc sulfate. So both in aqueous, means in the form of the ions. And this reaction is precipitate reaction, because we got here zinc hydroxide. So zinc hydroxide is white PPT. And what about the byproduct? Byproduct is here ammonium sulfide. Zinc sulfide ZnSO4 reacting ammonium solution. What is the formula of the ammonium solution? NH4OH. So gives white PPT. What is the formula of this white PPT? ZnOH taken 2 times. So it is the white PPT. Yes. This is the white PPT. This white PPT along with formula. What is that? Along with form means for one more byproduct, that is ammonium sulfate. Ammonium sulfate is the byproduct. Next, ammonia reacts with copper sulfate. CuSO4 is copper sulfate. In where? In aqueous water. So So presence of water, ammonia reacting with copper sulfate solution. So when it reacts with copper sulfate solution gives copper, okay, what? And ammonia water molecule contain complex. So here we are getting the complex. Cu NH3 taken 4 times, H2OL and SO4 acts as a counter ions. So here complex formation possible when ammonia reacts with copper sulfate, presence of the water. Next, ammonia reacts with AgCl. Yes, what is AgCl? AgCl is, okay, what is AgCl? Okay, AgCl is the gold chloride. Au is the gold, it is the what? Silver chloride. So ammonia reacting with here silver chloride, okay, and forms here, okay, diamine silver chloride. What is the formula of the diamine? How many amines group there here? So amine groups here, how many? 3, 2 there. Yes, so it is the diamine. Silver is the central ion, chloride is the counter ion. By this way, okay, ammonia reacts with silver chloride, forms diamine silver chloride. Diamine silver chloride. So here we completed the properties of the ammonia. So next 8 marks question. So what is the next 8 marks question here? How is nitric acid, how nitric acid is manufactured by Oswald process? So nitric acid HNO3 is called nitric acid. So nitric acid we prepared by several methods. In that, important method is Oswald process. So how we prepare the nitric acid by Oswald process? So nitric acid we prepared by Oswald process 3 steps. Step 1, Krishna is right. Yes. So nitric acid manufactured, okay, here by 3 steps. In that, what is the first step? First step is ammonia on oxidation gives nitric oxide. Ammonia, how many? 4 moles of the ammonia reacted with 5 moles of the H2. Presence of the PT or what? Gauge catalyst, where 500 Kelvin 9 bars. So we got what here? Nitrogen oxide is called nitric oxide. Now in second step, nitric oxide undergoing oxidation. So nitric oxide underwent oxidation given NO2, nitrogen dioxide. NO, nitric oxide, O2, oxygen, given NO2. This is what? Nitrogen dioxide. In third step, that is step 3, in that nitrogen dioxide on hydrolysis, given HNO3, nitric oxide. Byproduct is again nitric oxide, C. So this is the Oswald process. So Oswald process contains how many steps? 3 steps. What is the step number 1? Ammonia oxidation. Result is nitric oxide. Step 2, nitric oxide oxidation, given what? Nitrogen dioxide. Nitrogen dioxide in third step, hydrolysis, given HNO3, nitric oxide. So this is nitric oxide preparation method. Now, okay, after preparation of the nitric oxide, how we have to concentrate it of this nitric acid, HNO3, required to make the concentration. So how do we concentrate this acid? By 3 stages. Stage number 1, the diluted HNO3 is concentrated by distillation. So distillation, one of the separation method. To here, this distillation is used to make the concentration of the HNO3. Stage 2, 68% of HNO3 is dehydrated with the pure concentrated. Yes, means if any water molecule is there, we are removing by dehydration in stage 2. This also concentration method. So its result is 98%. Yes. So we got 98% HNO3 where? In the stage 3. Cooling in freezing the mixture. Yes. By this way, we concentrate the nitric acid by 3 stages. Stage 1, stage 2, stage 3. The end of the stage 3 we got here 98% of the HNO3. Now how does nitric acid reacts with copper, zinc, sulfur, phosphorus? Yeah. Next question. Okay, what is the next question? How does this nitric acid reacts with copper, zinc, sulfur? First question. First is copper, Cu. So copper is here reacting with, okay, HNO3, nitric acid. How to remember here? So we have to remember here 8 moles of the HNO3. Then only reaction we will get properly and be able to balance the reaction. So how many moles of the nitric acid? 8 moles. So 8 moles of the nitric acid reacting with copper filings and forms copper nitrate. Okay, and NO, nitric oxide and water. So this is the first chemical property of the HNO3 with copper. Same HNO3 here 4 moles. How many moles? 4 moles. These 4 moles of the HNO3 reacting with copper filings given CuNO3 taken 2 times. But here instead of NO we are getting NO to nitrogen dioxide and water molecules too. So here see, so rate of the reaction depends on the concentration of the what? Reactants. Here concentration of the reactants here 3,8, here 1,4 only. So that different we have to show here. Now zinc, with zinc HNO3 is reactive. How many moles? Here we have to remember 10 moles. So 10 moles of HNO3 reacting with zinc and forms zinc ZnNO3 taken 2 times. So how many water molecules? 5. How many nitrogen dioxides? 1. How many moles here? 4. Last reaction, nitric acid 4 moles, okay, that makes zinc oxidation. So zinc on oxidation with the concentrated nitric acid gives what? Nitrogen dioxide. Yes. Yes. And what ZnO3 taken 2 times to water molecule. Yes. These are what? Yes. Good evening. Any doubts? So any doubts regarding these reactions? Yes, students, please. Yeah, one student is available. Yes. Yes, any doubts regarding the reaction? Please see once again the nitric oxide, okay, properties. These are the nitric oxide chemical properties. Yes. Good evening. Yes, any doubts, please? Please, you put in chat box. You write in the chat box. Yes. Next. How does nitric acid reacts with copper, zinc and sulfur, phosphorus? We completed here copper, zinc. Now with sulfur, yes. Sulfur. What is the symbol of the sulfur? Yes. What is the atomicity of the sulfur? Yes. Atomicity of the sulfur is A because it is the octaatomic. Now it reacting with nitric acid. So nitric acid reacting with sulfur, octaatomic. Yes. So how many, okay, molecules of the nitric acid here? 48 molecules of the moles of the, okay, nitric acid. Now gives what? H2SO4 8 and NO2 48 and H2O 68. Yes. So you start the balance with sulfur. Yes. So sulfur here 8 sulfurs. Then here how many? Okay, hydrogens. Now next see. Then we will get here 48 and 8. Remember. Then we make the balance fruitful here. Now phosphorus. What is the atomicity of the phosphorus? 4. See. Reacted with H1O3. How many moles? 20. So here H3PO4 4 because phosphorus is there. Nitrogen 20. So hydrogens 4H2O. So hydrogens here also there. There also there. Here 12 there 8 yes total. Yes 20 moles of 20 hydrogens. So by this way sulfur with sulfur also nitric acid reaction possible. Result is sulfuric acid. With phosphorus also possible. Result is okay phosphorus acid. Yes. Now how ozone is prepared? Yes, ozone. So ozone formula is O3. Yes, O3 is called ozone. Ozone atomicity how much? So ozone atomicity is 3. So how ozone we prepare? Oxygen. Ozone is prepared when slow dry steam pure cold oxygen. Okay, is subjected into the electric discharge. That is called ozonizer. In that O2, okay, gives O3. How many here? 3. Here 2. The heat of reaction is positive. So this reaction is what type of reaction? It is, yes, it is endothermic reaction. Now, so chemical properties of the ozone. So ozone reacts with ethylene. Yes. Ozone is reacting with what? Ethylene. Yes. What is the formula of the ethylene? CH2. Yes. Okay. CH2 double bond CH2. Yes. And gives what? Ethylene ozonide. So when ozone reacts with ethylene, gives ethylene ozonide. Next, ozone oxidizes potassium iodide. So potassium iodide is what? Kl. In what is the oxidation state of the potassium? +1. Iodine -1. In KOH, okay, here I2, iodine oxidation state is 0. So -1 to 0 oxidation number increased, decreased. So oxidation number here increased. So what is the role of the O3? O3 acts as a oxidizing agent. It oxidized potassium iodide to iodine gas. So ozone oxidizes mercury also. How? So mercury is the liquid metal. So O3 when reacts with mercury, it forms mercurous. So what is the formula of the mercurous? Hg2O plus O2. Yes. So when mercury before reaction has movement because it is present in liquid state. When it reacts with ozone, it loses its movement. So that is called meniscus. Losing mercury its movement. When it loses its movement, it sticks the walls of the test tube. So that process is called tailing of mercury. Means mercury, formation of mercurous oxide with ozone. It is called tailing of mercury. Yes. So what is the tailing of mercury? Yes, tailing of mercury here very useful. It is in 8 marks and it is in 2 marks question also. So what is tailing of mercury? Mercury reacts with ozone, forms mercurous oxide. It loses its movement, that is called meniscus. So after losing its movement, it sticks the walls of the test tube. So that reaction process is called tailing of mercury. as after ozone, okay, reacts with NO, nitric oxide, and gives nitrogen dioxide. Next reacts with Ag, forms what? Silver oxide. So how many properties there? Property 1, reaction with ethylene. Property 2, potassium iodide. Property 3, mercury. Property 4, what? Okay, nitric oxide. Property 5, silver. Yes, these are the 5 very important chemical properties of the, okay, ozone. After ozone, we see how chlorine is prepared in the lab. So what is chlorine? Cl. So chlorine also from P block element. Yes. So chlorine, how we prepare? Chlorine we prepare by, okay, laboratory method. In that we are using NaCl plus H2SO4 plus MnO2s. Clear? We are using MnO2s. So what about here? First we will get sodium hydrogen sulfate. Next one, MnCl2 plus H2S. Clear? So last what? Cl2. By this way we prepare what? Chlorine gas. So it is the preparation of the chlorine gas. So NaCl, H2SO4 plus MnO2 gives rise sodium hydrogen sulfate, manganese chloride, water and chlorine gas. So it is the chlorine gas preparation by lab method. Now how we prepare the chlorine gas? By Decon's method. Yes. So Decon's method also there. So what is Decon's method? Preparation of the chlorine, okay, with the help of HCl. So HCl, 4 moles of the HCl react with which one? So oxidation, chlorine is prepared. Okay, atmospheric oxygen, presence of CuCl2. Yes, gives what? Chlorine and water. It is a Decon's process. So why? How to remember it is a Decon's process? So here copper chloride. Yes, copper chloride is the what? Catalyst. So we use here copper chloride. So we have to remember here easily Decon's process is presence copper chloride. Yes, next. So chlorine properties. So what are the important properties of the chlorine? Yes, in that first one, chlorine gas. Okay, reacts with cold and dilute sodium hydroxide. When chlorine reacts with cold and dilute sodium hydroxide gives NaCl salt. And what about NaOCl and H2O? So what are the products? Salt, NaOCl, H2O. This is the first property. Next, same chlorine that reacts with hot concentrated sodium hydroxide. Here, so we increased the number of moles of the sodium hydroxide 6. Now result is first NaCl, second is NaClO3 and H2O. Third, properties of the chlorine. Chlorine reacting with excess ammonia. How many moles? So 8 moles of the ammonia. How many moles? Chlorine with 8 moles of the ammonia reacted, given N2 nitrogen gas and ammonium chloride. So this also, okay, very important question. Which one? So preparation of the chlorine for 8 marks. First we write the first simple preparation. Next, Decon's process. Okay, after 2 preparations of the chlorine, the 3 properties. So property number 1 with sodium hydroxide dilute. Property number 2 concentrated sodium hydroxide. Property number 3 with excess ammonia. Yes. So these are the 3 properties. Okay, next 4th property. So chlorine reacting with dry slaked lime. So calcium hydroxide is called dry slaked lime. When chlorine we pass this gas into the slaked lime, It forms the CaOCl2H2O. Yes. What is this? CaOS. Cl2H2O. This CaOCl2H2O is called bleaching powder constituent. Yes. So CaOCl2H2O. Yes. Now this chlorine reacts with hypo. So Na2S2O3 is called hypo. When chlorine reacts with hypo, it forms sodium sulfate, HCl and sulfur. So it is useful to preparation of the sulfur also. It is useful to preparation of the sulfur also, yes. So it is the fourth property. Chlorine reacted with what? Calcium hydroxide. Chlorine reacted with what? Hypo. So then first one is, third, fourth one is bleaching powder, and what about the fifth one? Sulfur. Yes. So subscribe to our channel and press bell for notifications. Yes, clear? So how many questions? Okay, we seen today 8 marks questions. Yes, 8 marks questions. How many we seen here? What is the first question from this P block elements? So what is the first question? First question is, how does, first question is, yes, how is ammonia manufactured by the Haber's process? Okay, how is ammonia manufactured by the Haber's process? Now second one, how does ammonia reacts with zinc sulfate, okay, copper sulfate and silver chloride? Next, how is nitric acid is manufactured? So nitric acid is manufactured by Oswald process by 3 steps, and concentration also required of the HNO3. So the concentration of the HNO3 by how many stages? 3 stages. How does nitric acid react with the copper, zinc, sulfur? So these are the nitric acid what properties? So what is the first one? First one is with zinc. Second one is what? Sulfur. Next, phosphorus. So sulfur, phosphorus. How is ozone prepared? Next question, yes. How ozone is prepared? Write its chemical properties. So here we have to write first ozone preparation. Okay. How? By electrical discharge tubule ozonizer. Next, properties. Properties how many? First property is ethylene ozonide preparation, I2 preparation, okay, mercury oxide preparation. So next one, NO2 preparation and Ag2O with ozone. These are the chemical properties of the ozone. So after this question, next question is which one? Next question is how chlorine is prepared in the lab. So first preparation is chlorine in the lab using NaCl, H2SO4, MnO2. So second one is very important process, that is what? Decant process. So here decant process we using catalyst CuCl3. Okay, that is very important. Due to this catalyst only we have to remember this reaction is decant process. Next, the properties of the chlorine. In that first property, chlorine with sodium hydroxide, concentrated and dilute, and excess ammonia. Next, okay, what? Calcium hydroxide, it is called Slaken lime or lime water. Last is with hypo. So here chlorine reacts with hypo also, forms sodium sulfate. Yes. So and sulfur gases releases. So yes. Okay. Okay. These are what regarding our yes. So congratulations to all the students for the TS Eamcet 2021 results. So see. Next, Spark Academy NEET 2021 results. These are. Yes, thank you. So this session for us useful to write the P block elements 8 marks question. So in this session we discussed what? 8 marks question. So next session we discuss the 4 marks and 2 marks question also. And start what the next class we take the next lesson. In that we first finish the 8 marks questions. After we see the 4 marks, 2 marks. Thank you students.